Yeah, so, well, welcome everybody, and it's great to be back in a real room. And, it's like from 18 months of being on Zoom and Teams and all that kind of stuff, it's been a bit of a freaky experience for the ears, right? Because of the way that audio is done online. And, it's like, while it's great that we had all those tools, it would have been better if they were much more realistic, right? So part of what we're going to be talking about today is those kind of how do we think about a more realistic audio for kind of experiences in the metaverse in its kind of broadest sense, including things like video conferencing and streaming and how that's going to happen today. So do you want to?
Yeah. So just a hello as well from me. My name is Stefan, and just a little background on ourselves. So I've been a sound engineer for over 20 years, started as a musician and then went into post-production mastering, had a bit of a journey into cinema, and then later into art installation, sound designing, things like that. And about 6 years ago now, Garry and I started Kiniko to tackle spatial audio and bring a better binaural engine. And it was only 4 years ago that I attended ADC for the first time. I hadn't written a line of C++ before, so 4 years later, we're just about to launch our first product at the end of this month.
Yeah.
Using Juice.
Sure. and all the stuff, and all the videos from ADC, which were an incredible resource.
Yeah.
So I'm Garry. I'm also kind of a long-time musician and tinkerer with electronic audio equipment. But I'm also a data scientist, and I've always been really kind of interested in how to process lots and lots of data very quickly, right? And obviously that's really what we're doing when we're thinking about binaural spatial audio and how we do that in a very quick way. And so one of the things that when we kind of got to, or thinking about, being a talk, I think what Derek asked us, you should talk about what you're doing because it's so interesting. And we were like, okay, what should we talk about? And really what we were thinking was that the journey that we've been on as we try to do something very different in binaural told us some things that we often don't encounter from other people working in the space. So what we're going to do today is really talk about that kind of those kind of issues, the journey that we've been on, and some of the kind of insights that we've developed in building what we're talking about. And we will get to talk about what we've built, but not until the end. So in the next kind of bit, what we're really going to do is, so as I say, share some insights from that journey. And one of the things that we're really hoping to do is start a kind of conversation in the developer community, because there's lots of work going on in spatial audio, but hardly anybody's talking to each other apart from at kind of academic conferences where it's very locked into a very particular type of thinking about binaural, and there's lots to be done. And right at this point in time, spatial audio has this real potential to be big. You can see the kind of what's happening in Dolby Atmos and Apple Music and Netflix and, Roblox, like introduced, the third order ambisonic voice for voice communications recently and stuff. It's really kind of started to change. But today, one of the questions that we think is that a lot of this audio isn't really practical. And I guess that's really what we're going to talk about. And so, and in that context is really thinking about what's been happening in audio technology since the beginning, and the attempt to try and capture, record, and reproduce some sense of reality, right? So towards getting from how do we think of the development of audio technology towards a sound image, right? Which is what everybody's kind of working on, whether you're working in stereo or multi-channel or spatial, right? And so, and that whole approach is really about what the end user is doing, is want to kind of have shared exceptional experiences with a sense of presence. So when you go back and look at like early recordings and the way that critics were talking about them, what they're talking about is like how it felt like listening on the radio, although I felt like I was in the theater with the orchestra, right? And so you kind of have that experience. And so this first part, I'm going to do like this mad dash through history and like to just try and kind of contextualize this a little bit. And so the first place that I want to start is with the theatrophone and binaural audio relays, because this is kind of like a really interesting experience that Clement Adler invented. So back in 1881, he got these very primitive microphones that he put on the stage of the Paris Opera. I think there were 12 microphones in total, trying to kind of capture the space of the stage. And then they were kind of put into some primitive mix into 2 channels and then relayed over 2 kilometers to an exhibition hall in the World Expo, where then they were kind of put into a primitive crosstalk matrix so that what people could then hear with like pairs of like, really old telephone receivers was a sense of what it sounded like to be in the opera, right? It's kind of an amazing idea that that's what they were doing before we'd even done any kind of mono or anything else, that binaural was there right from the beginning. And so one of the things that kind of happened out of that is that from the theatrophone, it spun out all these subscription services, right? So the first streaming audio subscription services came after the theatrophone, right? So in the UK, the Electrophone company in London, right, on a Sunday, you could subscribe to the sound from 14 theatres in London and listen at home with your little kit, right? And so they had like about 2,000 subscribers at its peak, but it did run for 30 years. And it's like, that's kind of like incredible, but that's where we started in this whole journey. But the arrival of the loudspeaker and radio broadcasting, and if you ever thought of why radio broadcasting is called wireless, is because the thing that preceded it was wired audio delivered to the home, right? And it's like, and it changed that model. And so, but what had happened, it kind of followed that kind of one-to-one relationship of the early recordings where you had, one horn recording the sound, engraved to some kind of platon of the sound waves, and then listened back on a single speaker, and you see that in the 2 images. It's like basically it's just a one-way relay to that process. And so what you're really getting when you listen to that is just a sum of the performance. You're not getting any parts of it, and so you're just kind of listening at a single point in space to that process. And you get things like, extra electrostatic stuff improves the quality of the, so in the top picture is Louis Armstrong in a performance at Radio City in 1942. And you can still see there, even in that, at that point, it's the whole band is around one microphone, and it's still being broadcast on the radio, and radios were still at that point monophonic, right? And it's like, and that approach, so we've got no dimensionality to the sound whatsoever, but you're starting to kind of pick up the experience, and that's what people are kind of, starting to rush towards. And so later we get like, developments in stereo and the phantom image, that gives us our first one-dimensional picture, and, with Blumlein's pair and the use of the Haas effect or the precedence effect. And, we start to get this illusion of a sound stage, right? And it's like, this is going to be with us for some while in this process. And we start to get kind of, you need crosstalk to have those speakers mixing to give you the image. But with headphones, when they come along, you don't have any of that crosstalk. So the headphone experience is a little bit weird from stereo. And we still have that isolated effect in headphones today. And then that process, it starts to allow stereo to have what we kind of think of this as the space hack, because you start to get effects change, so you can have reverb and other approaches that are kind of adding to this sense of space, even though it's just still this one-dimensional image. And you get overdubbing, which is really just virtual audio. So that image at the top is Les Paul recording his wife, Mary Ford. And everybody thinks of Les Paul as like the king of the guitar, but he's also the godfather of multi-track audio and of overdubbing. So Mary used to record all her own harmonics, right? So harmonies, right? So she never sang with a backing group, right? So it's already at that stage thinking about kind of virtualization of the audio context into making something new in that approach. And obviously, as stereo develops, it moved away from the kind of wacky panning of early stereo to much more smarter use of that process. And then ultimately, we kind of arrive at surround sound as we're kind of getting closer to immersion, and we're now in like a two-dimensional forum. And, you know, we get kind of multi-track at home, leads to quadraphonic, a bit of a disaster commercially, and, you know, but kind of interesting as an idea, you know, trying to manipulate the sound on the perimeter of the 2D space. And then Dolby eventually solves surround sound by saying, you know, keep all the direct sound in the front and just have ambience in the back to kind of create a sense of a space and so on. So you can see this kind of development. But at this point, it starts to become problematic again with headphones, because what do you do when you've got 5.1? How do you listen on headphones? So like the earliest attempts to that were like multi-driver headphones, which I don't know if anybody's ever used any of them. They were incredibly like, well, just wacko really. You know, it's like, it wasn't like listening to a 5.1 setup. And then Dolby came with its application of one of the earliest HRTFs in the commercial space for 5.1. But I mean, that was also like really terrible. But, you know, as we're kind of moving on through that process. And then finally, it's like where we are today with things like Atmos and so on, we're kind of adding elevation and partial periphony, because these systems are only in the upper hemisphere. There's nothing below. So Dolby just starts at the ears and then goes upwards. There's nothing down. So, you know, how do you do footsteps in a Dolby Atmos system? Well, what you really need to do is you need to use psychoacoustics, which is that's going to become a little bit of a problem later. I'll come back to that. You know, and then you get all these kind of translations for the speakers. So if you look at the Atmos ecosystem, they're then taking Atmos into a 5.1, putting it into an ambisonic model, a first order ambisonic model, and then listening back with an HRTF. So there's lots of processing to allow us to move from the speaker format to the headphone format, right? And so there's all these kind of complexities that are emerging in this space. And Stefan, do you want to say something about?
So just recently when we started to build different VSTs and AUs and AAX plugins, we found what a jungle all of the different speaker configurations in this landscape is, and how much different formats there are, and it's quite a jungle out there. So you have stereo formats, you have 5.1 formats, different speaker orderings, different labeling. Now, recently, Logic added, or Core Audio added, the 714 format, and we found some speaker labels in there that come from early QuickTime days. So it's quite a confusing landscape, to say the least. And what we also found is, you know, on the other hand, you have ambisonic formats, and the two can't really mix together. So the paradigm of having a layout with speakers and a layout that is speaker agnostic doesn't really mix very well. So that brings us to the next point, I guess. We really regard the speaker model as technical debt. So what we mean by that is that every time that we think about spatial audio, we're thinking about it through the perspective of a speaker layout. But we are in a room here now. Yes, we have some speakers in the room, but when you have a conversation amongst yourself, you're not being projected through a speaker. You're projected naturally in the room as a monophonic sound source that is emitted in a space. So why is every production that we consider a mono stereo 5.1 production? Why is a track in a DAW always labeled as a stereo track, as a 5.1 track, and not just an audio object or an audio emitter? And it's, from our point of view, this is really hindering our progress as we step into the next stage of development of audio.
Yeah, so that whole idea of the kind of the phantom image that came with stereo did something amazing, but as it kind of grew and become more complex and multi-layered, it's actually leading us to a point where it's starting to be a challenge. So, and one of the reasons that it's a challenge is today, more people listen on headphones than they do on speaker systems, right? It's like, Well, the reality of it is since the early 2000s is like there have been more and more systems that are headphone dependent, and for a long time now, over 10 years, you know, headphones have generated more revenue than domestic hi-fi, right? And that's where we are currently. And if you look at streaming media and the dominance of Atmos, is, you know, that is really about people listening with headphones, right? So you can see this general approach in there.
So a couple of years ago, when VR started to become more important in 360 videos, we also looked heavily into ambisonics and thought, hey, yeah, finally no more speaker. We have a speaker agnostic system. We can direct the sound in any direction, and especially we can deal with head rotations in a 360 environment. We built speaker installation systems. You can see a picture here at the bottom. We did a 38 speaker installation just around the corner from here in St. Luke's church for Harry Potter and Audible at the time. So, you know, we had a really good look at ambisonics and what can be achieved in such a speaker agnostic environment. And, you know, it's an amazing system when you're coming from the rigidity of a 5.1 or a Dolby Atmos system. You have the lower hemisphere. You can use psychoacoustics to kind of give you a little bit of distance. You can use reverberations, ambisonic reverberations. We even went to the point where we took our own ambisonic AR impulse responses to give you a dynamism in the space. But at the end of the day, the system is directional. It's not volumetric. Ambisonics as a principle is the sound at the edge of a sphere with a radius. And even with, we're going to come to the different radii of Dolby later, but shall I touch on that now?
Yeah.
So if you look at the ambisonic or the HRTF model that Dolby Atmos employs, where you can put metadata in for near, mid, and far, these are really three different impulse responses, different HRIRs that give you a space, but they are at three different fixed horizons. This is not a continuous and volumetric environment. So from our perspective, ambisonics was great, and it was a great way to break away from that paradigm of the speaker, but it is a directional format. And that is very good, but that is also its limitation. Now, at the bottom, you see here the angular resolution of ambisonics. And if you think of first order taking 4 channels, and seventh order taking an internal of 64 channels of audio for the spherical harmonics, you still only get to a pinpoint resolution of 22.5 degrees. And that's quite coarse in comparison to what we as humans are able to detect in space. We can tell 1 or 2 degrees over a distance. So I think we need to go to 9th and 11th order, but the overhead for that is huge. The streaming that you would require to run these orders is not really feasible, especially not on mobile or on streaming. And the benefit you get from it is getting negligible, because you're never getting to the 1 or 2 degrees in that method.
Yeah, and then obviously the next problem is, so even if we've got ambisonics, is how do we listen to it on headphones again? Because the headphone is not going to go away as a delivery, as a playback system, you know, and there's a bunch of problems, right, with HRTF. So
HRTF in principle, so this was one of the things that first kind of interested us. Like, you know, we were making surround sound music in 2001. We started making our first electronic music tracks in Cubase at the time, and we always wondered, how do we get to a good binaural mix? And we used all sorts of different HRTFs, and they all sounded pretty bad. Lots of artifacts in them. The higher frequencies were not right. The bass was not right. And then we looked at the process of how do you create HRTFs. And at the end of the day, they are measured in an anechoic chamber with lots and lots of speakers. So the resolution that you get is as good as the resolution of the speaker system that you have. Sorry. There we go.
Yeah. So that process, so what you're really getting from HRTF is an emulation. So what you're asking the HRTF system is, what would the audio that you're trying to listen to in space have sounded like if you'd have put it on the speaker system in which you did the dummy head recording, right? So you're just emulating that process. And what happens then is that any other spatial acoustics that you want, like distance effects, so, drop off in the dispersion or refraction and so on, you've got to bake those into your sound design before they get directionalized, right? And so there's an image at the bottom there of Michael Abrash from Facebook Reality Labs. So kind of saying, wow, this is really the future. It's like we can do all these things and we can do them in advance and then mix them into an HRTF, and it's going to sound amazing, right? But actually, that's a mistake, because what you're doing is you're starting to mix different physics of the audio. So the physics of the audio that you captured in the head-related impulse response encapsulates the physics of that room at that time, right? And then you're then saying, and now I've got another scene that I'm in, that my scene is not like that the speakers are 2 meters away or 1.3 meters away, as they generally are, but my sound is 20 meters away, right? So when the head is trying to work that out, what is it listening to? Is it listening to the speaker in the HRTF, or is it listening to the sound that's 20 meters away, right?
Interesting debate. One interesting debate that we witnessed the other day on the Dolby Atmos Facebook group, which some interesting debates happened there about the subject, is that people are now questioning how the Apple HRTF sounds in comparison to the Dolby HRTF. And, people with speaker systems are advised by Dolby to use their speaker systems to create a good sounding mix. But people also want to hear how it sounds to the end consumer when they listen to it on Apple Music. So that there isn't a pipeline for that at the moment. There's no live pipeline for that at the moment. You have to create an MP4, upload it to the iPhone, then listen back to it, then go and make some mixing decisions. That's not a very pragmatic workflow. But there's, in our opinion, there's a big danger that people are now saying, oh, in order for the biggest market, which is Apple Music, to sound good, let's try to nudge it a bit so that it sounds good through their HRTF. But that means we don't have a good sounding master. We have a master that sounds good only on Apple's HRTF. And what happens if next year they change their HRTF? So we were always mixing, when we're mixing in stereo or other formats, and passing it to the mastering engineer to create something that universally works, hopefully for everyone to one degree or another. But going into the personalization and HRTF model, and then people adapting that into their mixing workflow, I think is a real danger of losing an overall and well-balanced master.
Yeah. So there's quite a bit of work going on to try and fix HRTF, but stay in the HRTF model. So that's where we started, actually, when we kind of started. We started 6 years ago, but we've been kind of thinking about it for about 2 or 3 years of kind of, is there a better filtering set that we could use than convolution? And would we get an improvement over that process? And, and we know a few other people that are kind of working on stuff like that at the moment, and it's kind of, it's taking you somewhere, but it's not really getting anywhere. And then Stefan's already mentioned, having multiple head-related effects so that you've got this kind of near and far. And one of the problems of that is, how do you crossfade between near and far, right? So if I want something that is moving away from me, it's like, it's great that I've got it on my near HRTF, but then I want it to be on my far HRTF, but what's the crossfade between that, right? It's like all these things are bringing in kind of like, when we're trying to model what sounds like in the real world, in these virtual worlds, we're starting to kind of hit lots of barriers in this approach. And, and there's lots of people who are saying, well, personalization is going to, change some of these things. And here's Michael Abrash again. So he gets lots of mentions in our things because he's always making predictions about HRTF that actually never come to pass. So in 2017, he said that personal HRTFs would be you would be able to go to like Boots the Chemist or some optician or equivalent and get your own personal HRTF, right, in 5 years. That's what he said in 2017. And then in 2019, which is where this image is taken from, he said, I've just had my personal HRTF done, and it's amazing. I couldn't tell the difference between the sound that I was listening to and the virtual sound. And it's like, but I'm not predicting that it's going to be 5 years anymore. It might be 5 to 10 years, but I'm still predicting it's going to happen, right? But it's really unlikely to kind of, that the idea that people are just going to be able to go and get their own personal HRTFs done is a kind of, it's probably one of the worst fantasies in the industry. And then the other approach to kind of personalization is all the ear scanning stuff that people are doing. Take a video of your ear and then upload it, and then some machine learning will have a look at the structure of your pinna and then say, you've got these kind of ears, right? It's like you must have this kind of spectral response to sound that's coming from above you. We'll give you this HRTF, right? And it's like, and there's lots of people doing stuff like that, but none of it is any good. The ones that we've heard, everyone that comes out, we try it, and you just go, why is anybody doing this? It's like,
I mean, it's an improvement on some of the other HRTFs that are out there, the generic ones. But in terms of timbre, in terms of long-time listening, it's really harsh sounding. It's really clinical and not really pleasant to listen to. Yeah. And I think especially, I mean, we spend a lot of time listening on headphones. After a couple of hours in a bad HRTF, you just want to die. It's not good. I get this phase kind of numbness in one ear when a HRTF is wrong, and this is not good for ear health. When we saw some kind of Zoom type conversations with HRTFs on it. It gets really stressful, and I personally think unhealthy to listen to that rather than a nice balanced sound, which is what we're after.
But then even if we solved all these things with all these attempts to fix it, what are we actually going to reduce in this process? Because we're still going to be listening to this sphere, right? It's like, so we reduce some of the confusions, like maybe we'll reduce back front confusion, where it's like it's difficult to know, exactly in front of you and exactly at the back, because all the time differences and the level differences are the same, right? So we might reduce some of those, but we're still going to be in this sphere. It just might be a better sphere that you're in. But and we're kind of getting to where we want to go with this. It's like in the volumetric metaverse, right, which we think is going to be much more about experience than the interface that you're listening to. So we're not really bothered about whether you're doing this in a VR kit or whether you're just doing it in something like Fortnite, where it's a 3D representation on a 2D screen and you navigate, right? We're not really kind of fussy about how that happens, because we think that it's just really going to be about three-world metaphors, and all that stuff will work itself out over time. But do we think that spatial audio is going to be the thing that's sort of a kind of presence maker, right? It's going to be the thing that says, oh yeah, I feel like I'm involved in this Travis Scott concert, right? Or whatever it is that's kind of going on. Whereas the visual stuff, unless you're wearing a headset, you're not going to get that kind of sense of presence. And and the one thing that you can definitely do with spatial audio is, like, without looking an absolute fool, is you can do it on the train or on the bus or whatever, right? Nobody's going to think, oh, these crazy people wearing headphones, which you would get that if you were wearing a Quest or something on a bus, right? And part of what we think is kind of coming is, like, streaming media is going to be the way that this gets delivered to the mass market. So you can already see, like, so Apple released with iOS 15.01 last week the idea of the shared experience, right? So that you and your friend who are remote from each other can watch a movie in sync. Right, so at the moment you're just watching the movie and there's no kind of interaction between you. But the kind of logical step of that is, the next kind of step is, you're going to want to sat on a virtual sofa together or whatever while you're watching it, and you might want to be kind of having a conversation. So now you're in this world where you want to have something that's really near field and changing all the time because of your response to what you're seeing, and something that's fixed in the distance that you're watching that approach. And it might be, if you're in a VR, it might be in a distance, or it might be one of you on the phone and one of you watching on your Apple TV or whatever. Who knows what that process is? But the audio is probably the thing that's going to unite you into a view of this world. And so that's kind of partly what we think is kind of coming, and it's what we've been working towards as we kind of get into the future. So do you want to say something about?
So to us, sonic reality, which is what we call it, is really a six-stuff space where users and objects can move around. So you have agency and you can explore the world, you can turn your head in any direction, but you can also experience objects that also have 6 degrees of freedom. And they're not just mono sources, they have a directivity pattern. So you might encounter a speaker in the virtual world and you walk behind the speaker and it should sound different than when you're in front of it. And really to enable this, to be able to create worlds like that, we can't really use the speaker-based approach to create a sound design. We can't use the ambisonic-based approach of us walking through a virtual reality and carrying a sound bubble with us. Because what happens when you have 2 people in a virtual reality? Are they just having 2 sound bubbles that clash into one another? We need a system that replicates how sound propagates in reality. We need a physics engine for audio and not a mix engine for audio. And that is really our starting point of thinking about where audio could develop to in the future in order to be able to create realities like that. And that doesn't mean that, should we go to the legacy content?
Let's just do
All
that.
right, okay.
So I think one of the places where this is going to be like most obvious is not in what sound designers and engineers are creating for the space, but what users are bringing to the space, right? So if we're expecting the metaverse to be like, you know, populated by user-generated content, right? They're not going to be thinking about the physics of the sound design and what it should sound like. You know, if you're in Roblox and you've just built yourself a flying machine and you've put and attached an engine sound to it and the machine flies away, it's like you want that sound to be realistic as it flies away above you, moves away into the distance, right? And that whole kind of process, you can't really do that with all the ways that we're working at the moment because it requires you to think about the physics in the sound design, right? And what we're saying is we need to separate that away so that there is sound design and there is spatialization. And so that's kind of, because what's kind of coming in that world, you can't have them mixed. You've got to be able to kind of make them much more realistic. Just like, you know, you don't have to think about, you know, if you're creating things in Roblox, you don't have to think about the lighting. The lighting is already thought about for you. You don't have to think about gravity. Gravity is thought about you. So why is sound wave propagation something that you have to think about, right? So that's kind of where we're heading. And what this really means is that we're probably on this path at the end of the idea of the mix, right? So the thing that we kind of inherited from the stereo workflow, that thing, the technical debt and the phantom image that continues to haunt us, it's like we're going to have to think beyond that. It's like right now people can still do mixers because we're in the very early days, but in the kind of near the more medium future, you know, that's changed because not everything's going to be mapped out. And, you know, audio isn't going to be tied to a path like it is today in those kind of worlds. And so the metaverse is going to be unmixed. So do you want to?
Yeah, so the thing, I mean, just picking up on that, it's like we have, you can still use speaker-based mixes in the context of these worlds, but they will live on virtual speakers in this world. And the world is not constructed out of these speakers. So I don't think that the tools and the methods that we have developed will go away. They're still useful. But the question for designing the Spatial Audio 2.0 is what kind of processes do we want to cherry pick from the plethora of effects that we've developed, and how do we translate them into this new world? So one of my favorites is parallel compression. I mean, in stereo mixing, wow, what a tool! But it's designed to fit everything into 2 speakers. what does that mean in a 3DOF, in a 6DOF world? How do we compress space? How do we parallel compress space? I think there's an opportunity for people that have been working in parallel compression to come up with a super solution for that. I think effects, I mean, you know, we will still have guitar amps in these worlds and distortions and things like that, but how do we reinterpret those effects for these new worlds? And I think it's as big an opportunity as going from mono to stereo. And at the beginning, stereo was not very well thought out. It took years before all these tools came to be and became useful and pragmatic mixing techniques. I think it's a great opportunity for everyone to just think about what are they doing and how will that work in that new world. And there's going to be new processes and new exciting ways to create sound.
Yeah,
that's what we are hyped about.
Yeah. So what we were building is towards spatial audio too, and what we've actually been building is a simulation-based sonic reality, so that the sound just travels directly to the ears and considers things like the medium in which the sound is traveling. So in our engine, in our VR, we have a VR engine. We have lots of engines for this, but we have a VR engine in which we can change the medium. So the medium can be air, or it can be water, or it can be custard, right? It's like, because we know what the physics are, right? So we're not really kind of limited to what that happens. Once we know the physics and we can describe it, we can describe the path that the sound is going on, and whether it's going directly, and how much of it is then reflecting, and when are the reflections arriving. And in the approach that we've been building, everything happens in real time, right? It's like there's zero latency in the process. Head tracking happens at like 3 milliseconds, right? You know, which is like a completely different world to like Apple's AirPod Pros. So we kind of like took us about 4 weeks to construct a test rig so that we can measure the motion to audio latency of the earphones. It takes about 200 milliseconds, but in the kind of the threshold that everybody really needs to be under is 30 milliseconds, where the brain can't distinguish that from reality. And the further you get away from it, the more the brain is aware of that distinction. And one of the ways of kind of focusing on this is that we then kind of have these high definition volumetric spaces where, what Stefan was talking about at the beginning, you know, where 2 and 3 degrees is not problematic for us, because we're not bound by any of these previous systems. We can literally say, you know, we've got two sounds, and as long, because they're arriving so we're also ear centric. So each ear is listening to the world in its separate way, and then your brain is making that connection. So as long as we kind of have that process, your brain, you know, the auditory cortex already knows how to do this. It's been doing it forever, right? And it's like, but it's not been processing HRTS forever, right? Yeah. And that's like a very different kind of way of thinking about it. And it takes us to a more binaural that's much more natural. And then we think the kind of next step from that, what we start to call next gen audio, because it is still kind of continuing with the sonic reality paradigm, but with more playback options. So with speakers, so it's like, you know, one of the things that, you know, it kind of takes us back to that mono thing. You know, it's like, if somebody is playing Fortnite on their mobile phone and they're listening to a mono speaker on their mobile phone, do they need to have a mono mixed soundtrack, or can they listen to a sonic reality? Just like if I was to take a directional microphone now and start moving around the space, you would kind of get a sense of the space, even though there's no spatiality to it, right? So it's going to take us back to where we were at the beginning in that approach, because we're now then saying, well, this is how I want to consume my metaverse today on my speakerphone, on my phone, on my speaker, tomorrow on the speakers on my laptop, later on my, you know, 22.2 Yamaha system that I've got in my bedroom or somewhere. Yeah, is that fantasy? So we're not kind of, so, you know, so we're not against speakers. We're just against the speaker, as the speaker workflow. Designing everything for speakers is problematic. It's like listening on speakers is all fine. It's just, what are you listening to? Does it have to be designed for speakers, and all the workflows with that?
Yes, I think I did that
You
slide
already
earlier.
did the legacy, so that's the,
So yeah, I mean, you know, there's nothing wrong with the legacy content, and there's nothing wrong in 10 years to still be a mono or stereo producer.
Yeah.
It's like there's always a Jack White that is going to go down to mono on live onto vinyl, but we can play that back in a virtual reality. So it's not about saying, hey, you know, there will not be a mix anymore, just in the metaverse. We need to consider that the end of the mix has come, and from our point of view, don't think that it's always a mix that builds that world. One of the things that we found interesting when we first started working in surround sound is how different your time perception is to composition, to a world, how your gaze is affected. Is there even a word for audio gaze? Not really, but your focus of what you're listening to in the world. And we found in numerous occasions when we try to bring music from stereo or surround sound into a virtual reality that it, for example, seemed rushed. Because as you're entering this world, you want to acclimatize yourself a little bit. You want to listen around and, oh, the verse has passed, I'm already in the chorus. So from a composition or a sound design point of view, you might want to consider working in this format and elongate time as you're creating this. So back catalog material can be brought into this world, but I think content should be created or could also be created in the world. There's a case for both, I suppose.
yeah. And so kind of going back to the idea of the speaker format then being, you know, the working around speakers being a technical debt, what we think really needs to happen in spatial audio is a kind of refactoring process in which we start thinking about the audio future, right? So that we don't wait to kind of arrive at all the kind of dead ends and cul-de-sacs that we're hitting now, and so that we can actually make that transition from the speaker workflow. So by inventing, you know, kind of designing new workflows and new tools and working out which tools we want to take forward, right? It's like, you know, we're all developers and we know that when we're refactoring, you go, yeah, I still want that bit of code and I still want that bit of code, but I don't want that code that Stefan left uncommented. Yeah. Right, so, and that's really that our kind of question is, what are we building for the future in terms of spatial audio? And that's really the end. So I kind of open that out to questions now.
Great, thanks very much. Really interesting stuff in there. We've got lots of hands up, starting near at this end.
Yeah, I'm just wondering, you've asked a lot of questions, but I wonder for you, I've listened to a lot of the generic HRTFs, and I find the same as you, that they're phasey messes a lot of the time and fatiguing. But one of the reasons stereo proliferated was because it was just good enough. So I want to ask you, what would be just good enough in this realm to create what you would consider a realistic HRTF?
Well, so we have our own engine that we obviously think meets that criterion. Just from personal listening, I think it has to have a balanced timbre, and you have to be able to listen to it for a long period of time. And that is something that stereo does over speakers. I find now, when listening back to conventional stereo over headphones, I find that is a very isolating experience because you don't get any crosstalk whatsoever. So especially listening to older material, that now feels wrong. Whereas, I mean, but I'm used to listening to our engineers, I suppose. That's, yeah. Does that answer it? I hope.
G'day. I was wondering, do you see a particular, that there could potentially be space for like a standardized, I don't know, like raycast-based positional system with occlusion built in as like a standard that audio, like that was kind of what I was feeling was coming through from what you were saying, was that maybe that's what we need to move towards, is rather than a speaker-based system, is something along that line. Is that kind of
that's exactly what we've been building, so that it's, you know, it's kind of it's, you know, depends on where you're implementing it. So when we're implementing it in plugins, probably don't do so much raycasting, but when we're doing it in other applications like VR and AR and so on, that's exactly what we're doing. And it's like, you know, if you follow me online and ask for, I'll send you a link to, like, we've got a really great video that we've built in Unity where we're in a room and we're just like, we let you hear the room excitation, and we can then just like put blocks in that are obstructing, and you put one block in and then another block and another block, and it's obstructing the audio, but you're obstructing the direct audio, but you're still hearing the reflections, right? And just just changing all of that so that you kind of get to that process where you go, actually, this sounds much more realistic, right? And that's the kind of thing that we would, and I think it's great for people that are already audio aware. You can kind of make all the kind of critical decisions where you go, I'll just leave that, that there because I know what's happening. But when we're kind of moving towards a more mass market consumption, people won't do that, right? You've got to actually give them something that experience is there. And I think it's based on that kind of approach.
Great, thanks. We've got a question on Zoom. Okay, question is, you talked about listening to personalized HRTFs via image capture and having negative results. Have you had any good HRTF recordings taken? Did you think these are good, as in indistinguishable from real life? And do you see a future in individualized spatial audio rendering if the method is improved?
But we listened to quite a lot of HRTFs. We had some measured and also spoke to people that went into labs and had it measured. But at the end of the day, our experience so far was that it never matched the reality of listening without a HRTF. And it definitely never matched the quality of listening to a good calibrated speaker system. So one of the things that I found interesting in just recently in HRTFs in general is, and I found that across most of the HRTFs, even when you're listening to a monosource in position center right in front of you, there's an imbalance between the left and the right. There's a frequency-dependent imbalance between left and right, which I think is probably also one of the causes why it's so difficult to measure loudness in HRTFs. So there's a huge differential. I found a plus minus 18 dB differential at some frequencies in the Dolby HRTF, and that's just listening to a mono source. So that, and the measured HRTFs that we come across, yeah, they match a little bit better the filtering of your anatomy, but in terms of sonic quality, sorry, not yet.
Yeah. I mean,
okay. I think we're running over a bit. Let's take one more quick question, and
it will be quick. Now, one of the things that I may have misheard in your talk that really struck me as a bit of a clash between my experience writing audio engines and analytics was when you said that, I think you said more people listen on headphones than speakers. So I had a quick look on Flurry for F1 Race Stars Analytics, and I saw 15.8 million people listening on speakers. This is a cross-platform game on consoles,
yeah.
PC, and on mobile, and 563,000 versus 15.8 million on speakers. Where do you get your figures from?
So the last figures I had were from Future Source Audio. So they had done some sampling in like 13 countries or something like that. And they had asked, what they'd asked consumers, where do they listen to audio and what's their thing? Most people had said, I think it was about, the balance was about 55% towards speakers. I mean, well, yeah. Yeah.
okay, great. We're out of time, but thanks very much again to Garry and Stefan from Kinnico. Give them a round of applause, please.
Thank you.